Hello everyone. In this video, we will focus on introduction to similar polygons, and this is the second part. I will put the link of the first part in the description box below. In this part right here, we're supposed to be solving for x, or the missing side of two given polygons that are similar. So let's take this first example right here. So we're given these two polygons here that are similar, and we're supposed to determine this value of x right here. We remember that two figures are similar if their corresponding angles are congruent and the ratios of the lengths of their corresponding sides are equal. So in this problem right here, since we say that these two polygons are similar, we can go ahead and say that if we take the ratio of these two corresponding lengths, the ratio of these two corresponding side lengths right here, and the ratio of these two corresponding lengths right here would be equal. So that's the rule in order that we can determine if the two figures are similar or not similar, so that we can solve for x here. Since in this problem we see there's like a lot of numbers around it, so we can go ahead and pick only two corresponding sides, so it's faster to solve. Now, the purpose for this is that I give you this trick because others can get distracted by all the numbers that are around there, and then they messed up with the ratio, and then they get the wrong answer. So in this case right here, since we're solving for x and the corresponding side lengths of x is 5, we're not covering this. So let's cover 3 and 6. So I have here a piece of paper that will cover this partner that we have here, or this corresponding side lengths here. I actually made also a general formula in solving for problems involving determining the side lengths of similar polygons. So we have here the side of a big picture over the side of the small picture is equal to the side of the big picture over the side of the small picture. Now we can go ahead and flip this fraction around. Once we flip the left side, we also flip the other side. So what it's trying to say is that if we get a 4, we can go ahead and say that would be side of the big picture. So that would be 4 over the side of the small picture, which is 2. So these two are corresponding. So I put 4 over 2, and that is equal to the side of the big picture is x, because I covered the other one so I don't get confused on those numbers right there. So we got an x, which is the side of the big picture. So I write it up here, and that is over the corresponding side of the small picture is 5. So that I can go ahead and solve for x by cross multiplying these two. So I will multiply the 4 and the 5, and then the 2 and the x. So I can go ahead and write that down here. So that would be 2 times x, and that is equal to 4 times 5. So 2 times x is 2x, and that is equal to 4 times 5 is 20. Now I want to solve for x, so then I can go ahead and divide both sides by 2, divide this by 2 here, so that we can go ahead and say that our x is 10. So the measure of this side length right here is actually 10, so that this picture would be similar. Now others are going to say, what is the purpose for that other measure that you covered? Does it really serve a purpose? Yes, we can actually cover that. This time around we cover the 4 and the 2, and then we use the 6 and the 3 instead of the 4 and the 2. Their answer should be the same, since we say that they are similar, so that we can go ahead and set the equation up here, so that we can have a side of the big picture. So the big picture here this time around it's 6. So I'm going to write 6. So this is the other way of doing it. So that is 6 over the small picture is 3, and that is equal to x right here. And that is over the small picture is 5. So I match it up. 6 over 3 and x over 5. So that we can go ahead and cross multiply these two numbers together. So that would come out 3 times x. So I'm just going to show the work down here. So 3 times x is equal to 6 times 5. So 6 multiplied by 5 is 30. And then 3 times x is 3x. No, we want the x by itself, so that we can go ahead and divide both sides by 3. I divide this by 3, so then we can cross this out. We're left with x is equal to 30 divided by 3 is 10. So our value for x is 10. Their answers are the same because we were using the 6 and the 3 ratio instead of the 4 and the 2. Now others are going to say, do we have to show work for these like two? It doesn't really matter. So when we say that it's similar, you can use any of these. It doesn't matter. The answer would be the same. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we remember that we are supposed to determine the value of x here so that we can go ahead and cover some of the parts that are that we might not need in solving for the x. So we cover this 9, and the corresponding part of 9 is 10.8. So I can go ahead and cover this 10.8 right there. So the remaining parts here are actually, we have, so that's going to be 2.4 over 2. So I write 2.4 divided by 2. And that is equal to, again, how I got this fraction. That's actually based on this general formula that we have right here. The side of the big picture, which is 2.4, over the side of the small picture, which is 2. And that is equal to the side of the big picture, 8.4. And it matches up with x, so I put x underneath so that we can go ahead and cross multiply these two and cross multiply these two. So this would come out 2.4 times x is equal to 8.4 times 2. So 2.4 times x is 2.4x, and that is equal to 8.4 times 2 is 16.8. We want the x by itself, so we're going to divide 2.4 from both sides. Divide this by 2.4. So we cross the 2.4 out. So we are left with x is equal to 7. So this is the length of the missing side that we have right here. So that should be 7. Now we can use the other covered part. So instead of covering the 10.8, we cover the 2.4 and we cover the 2. And then we go ahead and set this up so that from here we can go ahead and say that the fraction would be, so I'm just going to show the work down here. Okay, so when I did the work, the answer is still the same, which is 7. So the value or the length of this side right here is 7. Now others are going to say, can we use just one of these? You don't have to show both of these. I'm just showing you all the possible ways of doing it, since we have like a lot of numbers in there. Because others are going to say, like, what is this 2.4 and 2 then if we are using only 10.8 and 9 and 8.4 and x? So that I showed all the possible ways of doing it. Did you get the same answer as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya.